All right, guys, here's try number 2 on equations of lines. Hopefully I have actual volume this time. One of the major concepts with equations of lines is going to revolve around the concept of slope. Huge deal. If I were to ask the kids in class, most everybody would relate that, oh, that's rise over run. It's a comparison. This is a ratio comparison between the rise and the run of a line. Now you can compute rise and run by using slope formula. And you can recognize it usually as the letter M. It's also referred to as a rate of change. All of these topics are related when we're talking about slope. If I were to put a little graph here, all right, trying to understand that a slope that is traveling in this direction would be referred to as a positive slope. That's a slope that's going uphill, all right? A slope going this direction, this would be a downhill slope or a negative slope. A slope that is horizontal, all right? And let's make sure we kind of back up, understand that the true definition, this is a test question, the true definition of slope is that it's a measure of how steep something is, or a measure of steepness. So if we're looking at a horizontal line, if I was trying to walk along a horizontal line, if I'm trying to contemplate steepness, this would be a slope of 0. A vertical line, I doubt anybody's going to go walk up a wall anytime soon. This is either an undefined or no slope scenario. Okay? Other ideas that we're going to be investigating is if we take a look at this positive slope, if I had another slope that was parallel to it, remember the arrows signify parallel. If I had parallel lines, another test question, they have equal slopes, which should make sense. The steepnesses should be the same. Where it gets a little bit more difficult would be with perpendicular slopes or perpendicular lines. These are called opposite reciprocal slopes. What that means is if I have a slope, a rise over a run, if I wanted to convert it into a perpendicular slope, this is the symbol for perpendicular. It's like an upside down T. I would want the opposite, and reciprocal means to flip the fraction. So an example, if I had a slope of negative 2/3, the perpendicular slope would be a positive 3/2. All right? So slopes end up being a huge player in equations of lines. We have two main types of equations of lines. One of them is called slope intercept. This is one of the more familiar ones, y equals mx plus b. It's called slope intercept because we would need the slope, which is m, like we said before, and we would need the y intercept. right? But there's another way to write an equation of a line, and I'll be honest, I'm going to beg you to use this mostly. It's called point slope. It looks a little scarier, but I'll try and convince you why this is a better form to use. With point slope, I'm not going to be able to avoid trying to find slope. No matter what, I got to find slope. But the other thing I want to find is a point, x1, y1. But with point slope, any point works. With slope intercept, you got to find this y-intercept, which is where the line crosses the y-axis. That's not always easy to find. All right. So for writing an equation of a line, let's do a couple of examples. All right. Example 1. If I gave you a slope of -7, and I told you your line intersects the point 4, -5. If I was going to try and write the equation of a line, again, I'm going to recommend you use point slope. If I find the y value of a point, I find the slope, and I find the x value of a point, I can put a box around this and be done. Try and remember the slope goes right here. And here's my x1 and my y1. Well, x1, 4, goes right here. But be careful. See that it says x minus 4 now. So if I wanted to pull this back out, I'd have to change that sign back to what it is. But when I put in a -5, I would have y minus a -5, which is going to make positive. This is a great equation for a line. So I gave you a second example. What if I gave you the equation of a line? Y minus 3 equals 2 times x plus 1. And I asked you, what's the slope? And can you pull that point out of there for us to use possibly to graph? Well, let's see, the slope is 2. That's my slope right there. And the point, like I told you got to be careful. When I pull this back out, I'm not going to put a 1 here, because when the 4 went in, it had to change its sign. So when I pull this 1 out, I got to change the sign back. This is y minus 3. That must have mean we plugged in a positive 3. I have to change the sign back. So if I wanted to use this information to graph, first I'd use the point. -1, 3. All right, I plotted the point. And now I'm going to use the slope. The slope was 2. Change it to a rise over run by changing the number 2 over 1. Now all I got to do is rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I can do as many times as I want. If I run out of graph, I can actually go backwards by going down 2 and backwards 1. Because 2 over 1 is the same thing as -2 divided by -1. I can go down 2 and back 1. I can do that as many times as I want. Just don't forget to draw the line. We're graphing a line here. Okay? So let's go even one step further. Here's where it gets difficult. Let's find the equation of a line parallel to this line and intersects this point at -6 and let's say 7. So again, I highly recommend plugging into point slope because all I need to find is slope and a point, and I can be done. I'm already going to throw a box around it. Well, the point's pretty obvious. I'm going to go -6, which is going to change that sign, and I'll put the 7 in right over here. The only question is, what's the slope? Well, the slope of this line right here is 4. And if my line's going to be parallel to it, then I'm just going to also put in 4 and I'd be done. Just realize if that had said perpendicular, I would have to convert the slope of 4/1 into a perpendicular slope. Perpendicular slope would be the opposite reciprocal. So I just would have used -1/4 instead of 4, but I still would have used that point. So these problems can be difficult. We're going to work a bunch in class. Be patient, stay positive, and you'll be just fine.